The physician orders D5W at 75 mLs per hour. The 500 ml bag was hung at 10 a.m. It is now 1500 and you find 300 mLs left in the bag. The drip factor is 15 drops per ml. How much should have infused by 1500? So first we need to see how much time has gone by. So the bag was hung at 10 o'clock. It is now 1500. So that means it's been 5 hours. And the bag is running at 75 mLs per hour. So you multiply 75 mLs times 5, and that equals 375 mLs should have infused over those 5 hours. The physician orders 1000 mLs D5.45 NS to be infused over 10 hours. The drip factor is 15 drops per ml. The liter was hung at 1400. It is now 1800. 300 mLs has been infused. Calculate the flow rate for the remaining amount of fluid in drops per minute for the liter to finish infusing in the time ordered. So we want to know what to set the drops per minute at. So that's what our answer is going to be in, drops per minute. So first we need to see how many hours we have left. So it was supposed to be over 10 hours. It started at 1400. It is now 1800. So that means that we have 6 hours left since it was supposed to be done over 10 hours. The total to be infused was 1000 mLs. 300 has already been infused. So there's 700 mLs left to infuse. So now we can set up our problem. We have 700 mLs to give over the next 6 hours. We're trying to calculate a drip factor, and we have tubing that is 15 drops per 1 ml. Drops is calculated per minute. So we have 1 hour, we're going to convert to 60 minutes. And now we have our problem and just need to solve the math. So let's cross cancel out mLs and hours so that we're going to be left with drops per minute. 700 times 15 is 10,500, and we're going to carry over drops. 6 times 60 is 360, and carry over minutes. 10,500 divided by 360 is 29.16 drops per minute. But we can't have a 0.16 of a drop, so we're just going to round that down to 29 drops per minute. The order is 1 liter of D5LR with 40 millicues of potassium chloride to infuse at 75 mLs per hour. How many millicues of potassium chloride will the patient get in an 8-hour shift? So our answer is going to be in millicues per shift. Okay, so the order is 40 millicues.
Motion detected in the front yard.
per 1 liter. We're going to convert liters to milliliters. So 1 liter is 1,000 mLs. And we're giving it at 75 mLs per hour. And we want to know how much we're going to give in an 8-hour shift. Okay, so cancel out liters, milliliters, and hours so that our end result will be in millicues over shift. So 40 times 75 times 8 is 24,000. And then we put that over 1,000. 24,000 divided by 1,000 is 24 millicues per shift.